All right, let's get right into it. Today, we're going to deconstruct a really specific type of front-end architecture, one you're going to start seeing everywhere. On the surface, it looks just like any other React app, but it's actually built for a completely different universe, one that goes way, way beyond just living in a browser. So let's dive in.
So, take a look at this. You've seen a file structure like this a million times, right? App.tsx, index.tsx, the usual components folder. It feels totally familiar. But here's the thing. In this setup, these files are hiding a pretty big secret. They're part of this powerful shift in how we think about building software, moving away from these standalone websites and toward apps that are more like plugins inside much larger platforms.
So, what's the big idea here? Well, it's really a tale of two different worlds. In one corner, you've got your standard web app. It's the master of its own universe. It controls the URL, the browser history, the whole shebang. But in the other corner, you have the platform extension. And in this world, your application is basically just a tenant. It's just renting a space, a little slot provided by a much bigger host application. Think something like Docker Desktop or a big CMS. And that one little change in perspective, well, it changes absolutely everything.
To really wrap our heads around how this works, we're going to take a quick tour of the project. We'll start right where you'd expect, the application entry point. This is where our little extension first sparks into life.
Every React app has to start somewhere, and this one's no different. It's a pretty classic three-step dance. First, you've got your plain old index.html. That's the static anchor, the physical file that the host platform is told to load. Then, index.tsx jumps in as the ignition point. It kicks off the entire JavaScript party. And finally, everything gets neatly mounted inside our main app component. Simple, clean, and gets the job done.
Let's just zoom in on index.tsx for a second, because it's actually doing a lot of heavy lifting here. It's not just slapping app on the screen. Its job is to find that root element in the HTML, fire up React 18's concurrent rendering, which is super important for keeping the UI feeling snappy, especially if the host is busy. And it wraps our whole app in any global providers we need, for state management with Redux or for theming. Oh, and that React.strict mode, that's absolutely crucial here. It helps catch potential side effects and memory leaks, which is a huge deal when your app could be mounted and unmounted by the host at any given moment.
Okay, so let's move up to the next layer. We're getting to the real core of the application now. And this is where we see App.tsx get a completely new job description.
And here's the key takeaway, the thing you really got to remember. In this world, App.tsx is not just a simple router for swapping out pages. No way. Its number one job is to be the bridge, the main communication channel between all your React components and the host platform that they're living inside of.
So, what does this bridge actually do? Well, App.tsx basically turns into an integration hub. It's where you initialize the host's special SDK, like the client for Docker Desktop. This is what turns your app into a gateway to the host's operating system, letting you fire off really powerful commands. It also sets up the main visual frame for your extension. And, this is really important, it manages the high-level error boundaries. That way, if one of your components crashes, it doesn't bring the entire host UI down with it.
So, we've looked at the HTML, the TypeScript, the core components, but believe it or not, we still haven't talked about the real power player in this entire setup. There's another file in here that's the true boss.
So, let me just ask you straight up. We've seen the code, we've seen how React gets everything running, but what do you think is the single most important file in this entire project? I'll give you a hint. It's not a .tsx file.
The answer is Metadata.json. And to really get why, you have to compare it to the good old package.json. Just look at this table. Your package.json, that's for your build tools, NPM, Webpack, that sort of thing. It's all about build time. But metadata.json? Its audience is the host platform itself, and it gets read at runtime. It tells the host, hey, here's my UI, here's my icon, and here are the backend services I need you to spin up. So in a nutshell, package.json builds your app, but metadata.json tells the host how to actually run it.
This brings us to a concept we call the Runtime Contract. Just think of metadata.json as a formal, almost legal agreement between your little extension and the huge host platform. Before even a single line of your JavaScript gets a chance to run, this file has already laid out the terms, telling the host who the extension is, what it's allowed to do, and what it's capable of.
I love this metaphor. The source material calls this file the diplomat, and it's perfect. So what does it negotiate on your app's behalf?
Well, for the UI, it sets the title that you see in the sidebar and tells the host exactly where to find your index.html. For the backend, it can define what's called a sidecar container, basically a helper service that does all the heavy lifting. And for security, it explicitly asks for permissions. Your extension can't just decide to use the camera. It has to declare it right here in the contract. The host policy is always deny by default.
So we've got this runtime contract that sets the high-level rules. But how do we make sure our actual code honors that agreement, especially when it's talking to the backend or the host API? Well, that's where TypeScript comes in to enforce the deal. This introduces another key idea, the data contract. This is all about having a formal, shared understanding of what data looks like as it moves around the system. And in our architecture, that contract is written down and strictly enforced in one central file, types.ts.
And here is a perfect example of that. This TypeScript interface defines exactly what a container info object has to look like. It must have an ID and an image that are strings, and check this out, a state that can only be one of 3 specific values: running, exited, or paused. By defining this in types.ts, both the front-end component that shows this info and the back-end service that provides it are forced to agree on this structure. An entire class of bugs just disappears. So, when you step back and look at the whole thing, what's the big takeaway? The fundamental shift here is that we've moved from building these self-contained code-driven applications to creating metadata-driven components. The identity and behavior of our app are no longer defined just by the code itself, but by this external configuration file that directs the whole show.
And that leaves us with a final, pretty provocative question to think about. As this trend continues, and our apps become these smaller components plugged into much larger systems, are we entering an era where the metadata that describes our software is actually becoming more important than the code itself? It's a big question, and definitely something to chew on for your next project. Thanks for joining me for this one.